Good morning, all. Welcome to the Build and Video series. My name is Jigar Modi, and I'm working at Oracle as a Principal Program Manager for Oracle Cloud Infrastructure, mainly focused on high performance computing and GPU offerings. Today, we have a special guest with us all the way from Italy. Thank you, Pietro, for joining me. Would you mind introducing yourself and your role at Alef, and how do you help customers to begin with?
Thanks, Jigar. With pleasure. Good morning, all. My name is Pietro Lascari. I work as a delivery manager for Alef. We are an Italy-based company, and we produce solutions to the financial problems of public and private firms, banks, and insurance companies. We have an integrated software solution that mostly targets the needs of insurance groups, and it is called Insurance Data System.
Thank you, Pietro. So I see an architecture diagram on the screen, and I'm wondering if you could describe and walk us through the design and the process at a very high level.
As you can see from the diagram, the architecture for delivering our insurance data system is currently based on a database-centric client-server architecture. The components of the architecture are, starting from the top with the front end, subnet, you have client machines. Users access those machines and interact with the system through them. The access is done through the remote desktop protocol, and they can feed input data, prepare and submit workloads, extract reports with output results, and so on. Then at the bottom of the architecture diagram, you have the backend HPC subnet, where compute nodes reside. These instances are intended for long-running batch jobs for risk analysis and other simulations and computations. In the middle, you have the database subnet. Insurance Data System relies on the Oracle database as a relational database management system. The relational model is mandatory for us because of regulatory concerns. And on OCI, we run very large databases of several terabytes each.
So I have one more question about the architecture. I know that you have some high-profile customers using IDS in Europe. How do they access IDS on the cloud? Do they use load balancer and or any front-end utility?
As you can see on the upper left side of the architecture diagram, we have an IPsec VPN through a dynamic routing gateway implemented in our OCI tenants. And so we let the customers access, the business users access the system through the VPN connection. We normally don't have any public subnet or nor internet gateway. If internet access is needed from private subnet hosting instances, we normally do that by exposing an HTTP proxy, which resides on a separate VCN. In that case, it has, of course, internet or NAT gateway, and we let the private instances access like that.
Perfect. Let's talk about the networking component. So how does your resources in private subnet access internet if needed? So while implementing VCN or subnet, so do you have any specific networking configuration that you use? Do you use internet gateway to talk to the client over the internet?
We don't use any internet gateway directly. In the most complex scenarios, we use the private IP routing feature, so we can get more granular control over the IP traffic through a Linux instance with custom rules and so on. And the most important part, as I told you before, showing you in the upper left corner of the architecture diagram, one of the most important part is the IPsec VPN, which implements the connectivity between the on-premises and the OCI infrastructure.
I know all your customers, especially the big insurance customers, use a lot of compute power within OCI. So when are you using bare metal versus virtual machines? If you could give us more information on what shapes and operating system do they use, and also if you can tell us about auto-scaling feature within OCI that you use?
We decide this according to the complexity and the urgency of each workload, of course, by synchronizing the information with our business users. We assess the computing power needed for each workload, and we choose from between virtual machine and bare metal, and we understand which is the most appropriate shape to use. For high performance computing, we normally rely on bare metal instances providing full isolation with high frequency CPUs and with local NVMe storage. For the operating system part, we use Windows Server and Oracle Linux mostly. We also have some custom images which are Linux based. Yes, we do use auto scaling and distance pools functionalities, especially when the compute capacity has to be managed dynamically.
And also, I have seen myself that a lot of customers I talk to, they are kind of hesitant to start their cloud journey because of the security reasons. So that is a very important aspect in which is security for your customers too. I believe just looking at the diagram, you have Cloud Guard. So do you use any specific OCI services to secure your data and other resources within OCI?
Yes, I can confirm that the finance and insurance sectors are, of course, highly constrained by regulations. And we found out we are early users of CloudGuard, and we found out it to be a simple but yet powerful service, which can offer you a set of tools and recipes to keep a security posture with ease. Especially helpful when you are running wide infrastructure and when you are subject to internal and external audits, as well as you have to deal with the regulatory guidelines.
Got it. So that brings me to a question on database. So which specific application is using the database, and if you can tell us a little bit about how does the database interact with the storage service, especially file storage service?
Most of our applications connect to the Oracle database and rely on it for functioning. We use both the Database Cloud service and the Exadata Cloud service for the most demanding database workloads. We are using the file storage service that is connected to the database, our database system. We do that to deliver a copy of the archived Redo logs, Oracle archived Redo logs, to a shared NFS mount point. This is a strategy to reduce the recovery point objective in our case. We also use a file storage service, as you see from the diagram, to expose a shared NFS mount point on the HPC cluster nodes, so on the backend HPC subnet. And this is, we found out the file storage service be fantastic in terms of scalability when computing a message passing interface parallel workloads.
So another important aspect of cloud is, I know myself, I mean, you guys are using two regions within AMEA, London and Frankfurt. So is there a use case for your customers for business continuity, high availability, and disaster recovery? And if yes, probably if you can tell us more about how are you replicating the data across these two regions in brief?
Sure. We follow, first of all, we follow the best practices that OCI recommends by spreading instances, be it PDM database and compute instances between availability domains and fault domains. Moreover, we use the OCI block volume backup feature with our own custom policies to have the backups stored in the home region, which is Frankfurt in our case, and in a secondary region, which is London in our case. Regarding the Oracle databases, we follow the Oracle's maximum availability architecture documentation, which is a great reference when it comes to build solid strategies for backup restore, disaster recovery, business continuity, and availability. In fact, from the diagram, you can see this because we have a dynamic routing gateway interconnection between Frankfurt and London.
Right. Absolutely. That brings me to the last question. I know Alef is growing rapidly, and you have done some significant work using OCI. So if I can ask you, what is next that your company is looking to leverage OCI for?
Well, first of all, since our customers use insurance data system for always evolving projects, we are working every day on continuous adjustment and improvements on the software and also on the infrastructure side. Furthermore, we are focusing over a deeper integration between our software and OCI automation tools. For the future, we are also planning to use OCI services for applying machine learning techniques and for big data processing. We would like to leverage engines and framework like, for instance, Spark and Hadoop. Another possibility that we are evaluating is the one to publish our applications as software as a service offerings in the OCI marketplace.
All right. Thank you, Pietro. Thank you for your time, and it was a pleasure talking to you. See you again next time. Bye for now.
It was a pleasure for me too. Thank you, Jigar. Have a nice day. Thank you for listening.